So I want to share some insight about coding or subcoding the journey about data mine. So but I try to share some information from the customer perspective. So how to say under current core model is the deployment. How can we further to improve the real-time performance? Especially in current topics profile and share that some intelligent industry computing, we try to consolidate multiple workloads such as HMI, version control, etc. on the commercial off-the-shelf computing, like the PC platform or the ARM-based platform. So my agenda next is about the software-defined control system, and why this idea concept was raised by the ecosystem, and what kind of perspective. And then I will share some leading KVM-based the hypervisor solution. And then I will share some little bit information, very high level about even under the core model, the implementation can be further improve performance from based on the hardware and try to make best of hardware resources and improve the resources and this our real-time code. So you know that as the engineer or the college, so the control system is very high-end. You know, compare with our PC or phone. You know, you can install application on your phone. It's very easy. But you know, the impact is minor. In best cases, you maybe after you upgrade your iPhone, it will become very mental. And then you can purchase a new one. But for the control system, such as Siemens with scanner or some the CNC machine builder, you know, it's very expensive. Usually it's billion of the RMB or dollars. So even for some the profession, they need to invest more effort. Try to understand how we program the computer and how we maintain the computer. And you know that control system, their target, their workload is to create high state-of-art product. So the performance is the goal. So to try to reach that target, they need to have tailor their performance. Usually they need some LPGA or AC solution. So this cause some problems. So when the customer want to migrate their product, such as a new function, they have a headache. And the other issue is still some the social society issue, like with old age young engineer, you try to ramp up. They need long effort. So it's based on this, so the ecosystem is wondering how we can involve or improve some the architecture, such as this is well known as a 95 architecture. You know, current control system is try to follow this concept to create the best solution and make the best product. But you know, this kind of solution also is based on the fixed solution, like a fixed function, fixed hardware. But in current the industry for the zero area, such as the more customers, the more tracking order online, and there is the option or some requirement is varied. But so it raises a big question. So current originally the batch-based product. So it means that we need to adopt customer requirement is very quickly. Then and also we also want to reduce the cost and improve the flexibility. So we need to have some AI or intelligent function try to improve the entire system with the performance and efficiency. So all our ecosystem are is with this kind of architecture. So we can see that this structure is quite is simple, but in the end, it also follows SI-95 architecture. So there's a little bit that in the control side, like the L2, L1 is mostly the intelligent controller. We try to simplify more detailed layers to the edge control. And then on the back, like R3 is some intelligence and the industrial application. We made the consolidate modeling those applications on the on-premise cloud infrastructure. Then we can leverage those the rich compute resources, and then deploy more intelligent applications, such as we can constantly monitor the controller. So such as when there's some issue, the controller, such as even the ARM or Intel x86, the CPU, we also there's maybe some corner issue like the CPU will crash, or maybe the NIC crash, or a GPU crash. So if we can implement a telemetry, a function, we can constantly predict the issue, and we can replace the components, or we can get some insight to improve our design. The other is based on this architecture, we can manage the application as cloud the environment. In addition, the best of its advantage in architecture, there is no the barrier between the control and the intelligent application. We can share the data. Currently the control is the ecosystem. We invest its effort, such as how we improve some like the process automation, and we can add some intelligent function in this. So there are much more the specification about that. If you are interested, you can look and Google about it. So today, I try to focus on the R1, R2 is the intelligent controller. So usually we can see that all those functions can reside on the common hardware with virtualization enhancement. And then we can assign the multiple devices such as ETHCAT stack, the link to the motion control. So this motion control application can totally inclusively use this adapter and reach the high performance. And then the HMI, HMI needs the high rate display and some intelligent function. So we need this application use the GPU exclusively. And then etc. Yeah, we can use the logic algorithm and safety checks on common protocols. So either this can deploy as the virtual machine or container. So it's the freedom about this slides. Yeah, there's a couple of the benefits about that. The one thing is it's for the OEM, they can reduce complexity of the hardware design and the software design. So they can leverage more involving the commercial off-the-shelf, the hardware technology and performance, and improve the product. It means that they can reduce the time to market. The other is for the end user. Yeah, they can use the common hardware and reduce the maintenance effort. So last year my colleagues shared Econ solution. So on the Econ solution, so yeah, Econ is open source. and Linux Foundation, the product is open source like Xenomine. So it's very light and performance very good. Is good. So under the Acorn, Acorn is type 1 hypervised solution. So we can virtualize all the workloads as the virtual machine. Especially one difference highlights important about the real time. Real-time application such as Xenomine core module. Core module is the system can running as a virtual machine. Real-time virtual machine is above the Acorn. And all the other is like a non-real-time domain can also same as the non-real-time is the virtual machine. And the Acorn is try to orchestrate the real-time and the non-real-time is the communication and the resource allocation. So today is let's come to the Linux KVM. KVM is quite very mature. Mature is the virtualized solution. I report that maybe it's maybe it's the started as the Xenomine project. It's based on the notable kernel in the Linux mainline, and it's secure and flexible. It's very flexible. Since the KVM has a large community developers, so more of our industrial is invest large effort in the KVM. So, and also there's some project-based management solution. So if we compare with Acorn, Acorn is also is maintained by a small community, and it's very tough to the real time, so needs to sacrifice some features. On the KVM, so it supports the multiple operating system such as Windows, Linux, and etc. And also it can be quite portable. And plus with QEMU, is a very good match. It can provide the developer much of the advantage. And also it combines the support all kinds of the hardware virtualization technology, such as Intel is virtual technology. So in summary, that if the KVM is open source, since we have the large community, and so the development effort is small. So most of the company ecosystem can share the development costs, and is flexible and have more features. It can support the multiple the operating system, and since the KVM supports hardware virtualization topology, so the performance is good, and it also is secure. So let's look at the general deployment. So we can say that the Linux and Unity Linux and Primarty and Xenomine is the common is baseline. Is individually consists of the KVM the kernel. So on top of it, we can create some non-real-time application like Windows, Linux OS for some HMI and AI, etc. But on the real time, such as the Xenomine the stack, usually used on the host OS, is quite different from the Acorn deployment. Why? Because then the KVM meet both flexibility and performance. So there in some cases it will cost a lot of the KVM context switch, context switch is very high, very expensive. Is the function core is a virtual machine. Usually, one is the context switch. Is the total time is about several is the microseconds. So it's the best the headed to the real-time application, such as in the real-time application, such as in the CNC, like it's the 8-axis, or it's the cycle time maybe it's the hundreds of microseconds. So it means that this is could be a big challenge. But on some is the robotic or some is the process automation, like maybe it's sub is the milliseconds. Yeah, it's good. It's good. So it means that the entire ecosystem will work together to improve this real-time performance. So we can make it both in the flexibility and the low cost and high performance. So in general, I believe all is and include myself, spend more time try to improve the performance, the real-time performance, such as it generates the methodology of the real-time performance the journey. On the system software, it includes usually on the ARM is the board support package, such as Linux kernel and Xenomap. So so we invest more effort try to tailor the kernel configuration, such as turn on the priority and reduce some unnecessary services, or is try to ban some of the actually non-real-time service from the real-time service, such as the last year. For us, we just identified one issue about the timer migration in our SD-ICS platform. We noticed that maybe in some current cases, we can run the 72 hours the stress test with cyclic test and stress NG. So this timer migration will cause some sporadic is the surging. So we identify that we have to change the code and maybe build some individual patch to mitigate this issue. So all the software engineers spend more effort about this part. The other is about EasyPad master or the Profinet, it's in Siemens. So we also invest more effort on the EasyPad master stack. So more straightforward, we try to use the real-time application to inclusive use technique. The other is we need to reduce the memory copy through the zero copy. And then we also try to reduce the complexity of the network stack, such as whether we can, as the dynamic domain, it can use directly send or receive the packet to the Linux stack, or we can such as maybe we can adopt such as DBTK solution. We can implement some of the user space stack, and then the real-time application can easily send and receive the packet. We also can make use of the hardware features, such as the preference features in the NIC, so we can reduce the feature, and then we can reach performance. The other is, we need to steal some help from our board is the vendors. So whether we can optimize the BIOS, tailor the hardware power management, such as keep the CPU busy, not lower the frequency, etc. And tailor the PCI speed fabric, and reduce the time saving, disable time saving in some of the PCI device, etc. And then is the firmware also needs such as in the x86. So one of the challenges is the SMI. Even if after the CPU is under SMI, you need transparent to the software, such as we can take a simple example like a container or the virtual machine. So once the hypervisor takes the ownership of the CPU, the virtual machine is nothing. You believe that I'm still maybe under the context switch mode. So it seems to the SMI. So once the CPU is under SMI, the entire operating system will stop. So to wait the firmware complete the operation under the SMI mode, and then return, it will cost about 100 microseconds depending. The other is the hardware level. The entire the CPU is the ecosystem invest more effort on the hardware, try to improve the PC-based hardware performance to reach the ASIC performance. Intel is invest a lot about it here. Now I'd like to take two examples about how to improve the real-time performance. One is straightforward, so when we improve performance, we really consider the CPU is the boundary, CPU affinity. But you know that for most of the developers, we may ignore the underlying the architecture, such as even when you binding CPU, is that right CPU? Maybe the two CPUs reside two clusters. This will cause some the memory or data sharing the penalty. Such as one CPU share the data must cross the CPU bus or the main memory controller to test the data. So the performance is not allowed in the high-end such as CNC machine. So the good is on the Linux we have two, like try to guess the CPU topology. So under this, we can guess what kind of the CPU look like from detail, such as then our system engineer can get the right CPU and use it accordingly. So based on that, we can modify the KVM configuration and create a good configurations. Then we can get better data. So same as a PCI device, it's on our board we have a couple of the PCI slots. So based on this CPU topology, we can need the port for the valve and get the right slot. We need the real-time the application as the data directly and quickly. So the other is the one of the second thought about the CPU binding, affinity. The CPU, have a couple of cache, one R1, R2, and last level cache. So when the cache, is shared, as a percent of time, tells us the cache is shared resources among all the entire CPUs. So such as the real-time application become active. If you move all the data from the main memory to the last level cache and R2 cache. But one thing is try to send the package. This data, not hot data. But it will need in the next cycle. But the Windows 7 become active. If you in some cases the resource is not enough, it will flush the cache. So it means that for this real-time application, it have to retrieve the data from the main memory. It will cause a lot of the issues. So our engineer did quite reach out to Panama to try to measure the memory throughput and R2 and R1 system throughput. So they have a lot of data, but I will share your interest arbitrarily. So in the end, that is we can use the current link tool to retrieve the cache topology and divide it carefully and bind the cache to the above the applications. So generally, the benefit is smaller compared with the system level. On the system level, we can reduce the real time from the milliseconds to the sub-milliseconds. But when the cache is the isolation, so usually it's the benefit about maybe it's a few is the microseconds. Okay. The other is about the CPU is the frequency. I believe in general in all the CPUs, such as ARM and non-ARM. For our customer, we have a best node method, is the pick推荐. We usually suggest the customer is to fix the CPU frequency. But our customer, like Siemens and backup, and also is our PLC customer, they will challenge us. In our the PC, PC the CPU, they will ask, since your Intel CPU is heavily adopt the PC architecture, why you try to fix the CPU frequency and disable all the power management features. So that we after the investigation, we found that we can use it. So it means that we can enable the function, but we need to carefully configure the system. So in the end, that is the set. So in the end, we can examine the entire the system and the resource allocation, such as the module 5 and 6. It will be used by the real-time applications, and other will be consumed by the non-real-time applications. So maybe we can consider raise these CPUs, those CPU frequency to the higher, and let others CPU frequency managed by the power management system, such as the underlying hardware is the scheduler. So we do a good benchmark. So we model that all those real-time CPU will running consistently under a higher frequency. Other is the CPU will fluctuate based on the workload, such as when you open the Windows, running the HM application. If the power is the envelope permit, maybe the core 0, core 1 is assigned to the Windows. You is under the turbo mode. But after a while, once the system detects the power is the limitation, it will reduce the frequency. But the real-time, the high-quality CPU core was not affected. You run constantly with higher CPU. So it means that good to for the customer. If you run this control application, it will get a better performance. So also it's another is the recommendation that is the other like efficient core. Since all those efficient core is share one cluster, it means that the CPU is the management is shared. So we cannot assign maybe the core 8 and core 9 and the core 6, 7 to non-real-time, one other to the real-time. So we can do that. Maybe in the future, if the architect design, we can add such feature and just the performance core is frequency is the good general added clarity. Okay, that's pretty much about my presentation. So feel free to ask any questions.